And I am the man who does statistics whenever I can. Cause statistics I can. Let's step into something a little bit harder. We are going to do chi-squared goodness of fit testing. For this, we have percentages that we are told, according to Ask.com, are the percentages of people in America. 40% are white, 30% black, 15% Asian, 8% Hispanic. Some of the numbers I may or may not have made up, but I did look up what the politically correct terms are for these people because I'm just sure I'm going to offend someone if I don't. Other captures all the, we could list all 20 and yeah, it'd take forever. Okay, so here's the percentages of people in America, and let's say they're randomly visiting the airport, and the airport tells you that they randomly select people for their full body scan check, and we are wondering, is it really random? Now, if we looked at it, they're pulling more white people than anything else, but is it close to 40% the way it's supposed to be? Well, let's look at the next 500 people who get randomly selected for the colonoscopy and find out how many of each of these categories they were in. Okay, so for the whites, we've got 180. For the blacks, we've got 135. And then we've got 90 and 50. 90 and 50. Now, is this last category random? And the answer is no. If I told you it adds up to 500, I can tell you how much goes in that last category just by taking these guys and subtracting them from 500, which I can do in my head, and I get 45. Okay, well, we were supposed to have the fewest in the other category, and yeah, it is fewer. Hispanics a little bit lower. It looks like this just might be reasonable. Could it be, or is it off a little bit? Well, the way I would find out is by saying how many would I expect in this category if it was truly random. If these 500 people were totally randomly selected, 40% of them should have been white. What is 40% of 500? That would be 200 people should have been selected for these random full body checks. There was only 180. Is it that they are underrepresenting whites? Well, let's keep going. 30% would be 150, but there's only 135. Blacks are also underrepresented. Here we were supposed to have 75 Asians selected and 90 were selected. Are we picking on those of the Asian demographic? 40 was supposed to be, but we selected 50. It looks like Asian and Hispanic are being over-selected. 35 others, and it was actually 45. Okay, so you can imagine how the headlines would read, whites and blacks are getting through the airport easier than they're supposed to, whereas other races are being targeted. But there's randomness here. Is there really that big of a difference? Well, labeling this as the observed row and labeling this as the expected row kind of gives you a hint as to what we're going to do next. It's going to be a chi-squared row just like we've done before. How do we calculate chi-squareds? Same way we did before. What's different is we got these expected values as a percentage of the total instead of this row times column over whatever, because there's not multiple rows here. So now we get these expected values just by reading the question and saying, how many should I have gotten in there? This chapter, you have to read the question a little more carefully to understand where those expected values come from. There's no easy equation, but on the other hand, there's no equation you have to calculate, so it does make it a little bit easier. Can I get these chi-squareds? Well, here's what it would be for whites, for blacks, for Asians, Hispanics, and for the other category. So if the TSA at the airports is targeting some certain race or other, which races would be most likely to complain? This guy here's got the biggest chi-squared. It's the Asians. We were supposed to select 75 Asians. We're actually selecting 90. Why is it that Asians are being targeted? There's something going on here. It would be very interesting. Who are they not targeting? Well, they're definitely targeting Hispanics. The whites are being left out, even more so than the blacks are. So you can look at these and say, okay, this is where the targeting seems to be happening, but is it provable or is it just random luck and chance? So let's write out our hypothesis test. We can get the null, which says that the TSA is not targeting specific races. In other words, these percentages of how many people are going through the airport match how many people are being randomly selected. The alternative would tell you that there are certain relationships. There is a relationship between which person is randomly selected and their race. There is some correlation going on. So we can get our chi-squared test the same way we've done it before. You add all these guys up, and that gives us 11.86. Now, before we can justify this, we need to say, do we have enough data? You're supposed to have at least 5 as all these expected values. And our smallest expected value is 35. So yes, we have at least 5. Now, what about our degrees of freedom? Before it was row minus 1, column minus 1, but we don't have multiple rows. Row minus 1 would give us 0. 0 degrees of freedom will break the applet. Don't try it. So what we need to do is come up with a new rule. If I knew the total was 500, how many of these would I still not be sure about? And the answer is all except the last one. So the rule is our degrees of freedom are k minus 1, where k is the number of categories. K stands for categories. I'm sure it has to do with the German language because I think they spell category with a K. Why we're doing that in English, I don't know. Let's just deal with it. K minus 1. In this, how many categories do we have? 1, 2, 3, 4, 5. Our degrees of freedom would be 4. 4 degrees of freedom, what's our p-value? We're going to come here to our little applet and click on switch to chi-squared. Degrees of freedom in this case is 4. I don't have to change my degrees of freedom. How do you like that? Our chi-squared value was 11.86. I forgot to flip sides because chi-squared tests are always right-tailed, and there is our p-value. Our p-value was 0.01840. I can't see it because the thing is 42. So our p-value is less than alpha. We reject. Please tell me by now you've gotten that straight in your mind so that you're not still switching them. Reject means we can conclude this. What's our headline going to say? TSA targets certain races. Now, which races wasn't exactly what we were testing. We were just testing whether there was a relationship between the race and whether they were selected. But certain races are being targeted. That's cool. That's good news. Most students in this class say that this chapter is the easiest chapter of the whole class, unless you're lost, in which case this is just piling more on. If you feel lost with this chapter, come see me, come see a tutor, send emails, find help fast.